Welcome back everyone. In today's video about multiple linear regression, we will predict using multiple features. So let's start. So these are all the topics we will cover today. Welcome back. In our previous projects, we learned how to predict a value using just one piece of information. But life is rarely that simple. Today, we are moving beyond the single line to multiple linear regression. We are going to teach our computer how to look at several clues at once to make much more smarter predictions. As you can see the example, there are total of four different lines. We are using four different features to predict a single target or any class. So, what exactly is it? Multiple linear regression is a statistical method where we predict a single numerical outcome, like the price of a car, using two or more input features. While simple regression is like looking through a keyhole, multi regression gives us the full view of the room. This is the main formula behind this multilinear regression, and this is just like the example, we can use this formula to predict using different features like x1, x2, and like that. Okay, let's use the house as our example. If we are buying a house, would you only care about the square footage? Probably not. You all had look at the numbers of bedrooms, how old the house is, and the quality of the neighborhood. Each of these is a feature that helps us to guess the final price of the house more accurately. Okay, so this is another example where different features are like finance, healthcare, marketing, real estate, and supply chain. These are all the places where linear regression is used. If we have only single feature, we can predict the finance or healthcare, but to get more accurate results, we use multi-linear regression so that we can get the outcome more accurately for any new data, for any of these fields. Okay, moving forward. Now meet the features. In our code, we call these inputs independent variables. We label them just like x1, x2, like here x1 and x2, and so on. For our house, x1 is the size, and x2 is bedroom count, and x3 is the age. The more quality features we give our model, the more context it has to work with. So, if we give more features which are important to our prediction, then it trains our model well, and the next prediction for unknown data, it gives us higher accuracy. Moving forward, the goal, the target. What were we trying to find? Is that target or the dependent variables labeled as y? The y. In this project, y is the total price. The model entire jobs is to look at all these X features and calculate the most likely value for the Y for predicting the house price using multiple different features. Okay, just moving forward. And the maths, how this works. Think of the maths like a recipe. The model assigns a weight and configuration to each ingredient. If location is the most important factor, it gets a heavy weight. The maths look like this. Price equals size times its weight plus bedroom times its weight plus age times its weight. It's a weighted sum of all these clues. Just here you see the size, bedrooms, and ages. Using all these multiplied by weights, all have different weights according to the importance or the, you can say the variables, the importance of the variables only. Okay. Using all these three, then we calculate the final predicted price. This is how the maths work. Weight into size and plus weight 2 into bedrooms plus weight 3 into ages. This gives us the final price. Then it's a question I think many of you has or think about it. Why not just use one feature? If we only use one feature, we might underfit the model, meaning it's too simple to be useful. By adding more features, we reduce the error. We get a bigger, clear picture of the data, which leads the prediction you can actually trust. Here is the example. In the simple linear regression, you have a variable, x variable, and simply we are finding the y variable for like the measurements. And in multilinear regression, we have two or more x variables like the C grades and the person's age. Here we are measuring simply how much they consume. Here we have the number of the cigarettes and the age of the person. Uh, Using both of these, we can actually calculate how much they consume. You're using the by simply calculating their age and their lifestyle, we can check it. The data shape. Because we have multiple features, our data now looks like a table or a data frame. Each row is a different house, and each column is a different feature. We all use the pandas library to keep this organized and easy to read. Just like this, in simple linear regression, we have only one features, single feature that is incompatible to see the whole picture of the house or see how the house looks like. As we have only single feature in this, we have only the size of the house. So this is the size. We can't say how it looks like, how it is, and just like that. But in multiple linear regression, we have the size, we have the age, we have the rooms, we have the location of the house. So we can picture the house more accurately and the error goes down, simply we can predict the house price more accurately. Moving forward to our step first, loading the data. First, we load our data. This is where we act like data detectives. We check for missing values and ensure all our numbers are clean. Remember, your model is only as good as the data you give it. So, before moving forward, let's go to Jupyter Notebook and code side by side. Here's the example. We have provided the x1 and x2 as two features, and we have to predict the y. Okay, these are all the data points. Let's go. Simply Jupyter Notebook. Give it a second. It will open, and here we go. Course. We will create a new Python file, and in this, we will start our coding part. But just a second before that, we will name it as multilinear regression. Multilinear regression. It's multiple linear regression. Here we go. Let's start. So first we will import all the necessary files, libraries, or any tools which we use in our coding part. So first we will import pandas spd. Give me a sec. Okay, now we have imported the pandas. We have to import numpy as np, and then we have to import matplotlib dot plot. This no, just go. This is for the plotting of the graphs, and now from sklearn dot model selection, we will import. I always forget p. Import train test split, train test split for the data separation part. And now from sklearn dot linear underscore model, we will import linear regression. We will use this model only, but we will change the feature later on, or we will change the parameters of this model later on for multiple linear regression. Okay, now from sklearn import. I always forget P. Import matrices for work on. Simply run this and lean. Okay, it's model. Simple typo mistake. Let's load our data set as we have to y- predict. We are using the example of prediction, house price prediction. So we will load the data set. So we can use a simple dictionary to show the table structure. So we will create a dictionary, then we will use that as our data set. Okay, this is our data and simple. We have for size. Oh, my mistake. We use 7 different columns or 7 different fee features of 7 different houses for this. First, we will randomly allocate the values. Okay, I think 12,000, 2,000, 1,200 is okay. 1,8 and now 4, 1,3 and something smaller. This is good. Comma. Next thing is bedroom. Bedrooms. We will use bedrooms for I think 3. Good. 4, 2, 3 again. I think 4 good. 5 and 1 we will go with 2. And then we will use the parameter age, the house age, how old the house is, and this is older than 5, we will give it 15, and then 8, and this is the newest. No, we will make one also, and this is the oldest 20. Just forget the comma, and now the last we will use price. So this parameter or this value is for the prediction also. So we will give it 30. How much we think? Okay, I think this is enough. And for this, we'll use this much. And for this, 35 and 48. 48, I think good. And 60. And last one is 20. As this is the oldest house. Now we will convert our data to a data frame. Simply we will type df equals to pd dot data frame, and in this we'll use data. And now let's check our data frame, simply predicting the top 5 rows of our data frame. We will print This is our housing data table. Let's delete. And now print. We will use the top five at if we random. Oh, sorry. If we don't put any value here, it's by default gives us the top five. Okay. If we want if we want more, like we use the parameter as 10, then it gives us the top 10 list, top 10 house prices. But as we have only 7, that's why it gives us 0 to 6. Like that, you can change also. If you use 2, then it gives us only 2. So we will use the default only, the top 5. And if we need the data from the bottom, so we will use print df.tail, and in this it also gives us the data from the bottom. As you see, this is from 0 to 4, the top 5, and this is from 6 to second, 6, 5, 4, 3, 2, the bottom 5 from the last. We can use the tail function here also. This is the same as the head function. By default, it gives only the 5 values, and we can change the value we needed by changing the parameter. Okay, so moving forward, let's see the next step in our presentation part. Then we come back to our coding part. Let's go. Let's go. Sorry. Step 2, splitting the data. Next, we split our data into a training set and a testing set. We let the model study the training data to find the weights, but we hide the testing data. This allows us to give the model a final exam later to see if it truly learned or just memorized the answer. So let's go back to our coding part and use or split our data set so that we can use some for testing part and majority of the data for the training part. Here also you can see the example of the linear regression and multiple linear regression, as it has two different variables to worked on, two independent variables to worked on for finding the y. So it's more looks like a 3D plane than a simple straight line, 2D straight line. Okay, here we are. Now we will split our data. Here we will use x as a parameter, and in this we will use the data frame, and from this we will use size, bedrooms, and age. For as these are all the features, just a second, I will tell you. Just I will use the y parameters, then I will tell you what both these are, df and here price. And here you can see we use we total have four different parameters or four different columns in this. First, we will using the first three, the size, bedrooms, and age, as our features of our model. We will use these three different features to predict the final feature, the last column, the price. We will use this as our target. So these three are features: size, bedrooms, and age, and the price is our target. So we will use these three to find the price. Okay, this is simple. Don't overcomplicate this. Just once more, I will tell you in simple words. We will use size, bedrooms, and age. These three columns to predict the last one column, the final price. In simple linear regression, we only use this. I am giving you just example. We only use the features, the size to predict our final target, the price value of the house. We will use size of different houses and we will predict the we will train the model according to that only single feature and then we will predict the house price for a random or new house size. But in multiple linear regression, we use three different features: the size, bedroom, and age. We will combinedly use all these three and we will predict the house price more accurately. And I think this gives I this gives us the better output as compared to simple linear regression. Okay, so now we have used we have taken the x the features. Let's simply comment here. These are features. Sorry, this is Python features. Oh, let's remove the C by mistake. And this is target value. This is our target. Simply use these three features to predict the target. Okay, moving forward. Now we split the data into 8 by 2 ratio, 80% for the training part and 20% for the training. Oh, sorry, 20% for the testing part. So simply use X train, comma, X test, and similarly Y train, comma, Y test. And in this, we will use train, test, split. And for this, we will give the parameters x, y, and test size as 0.2. And we will use random state as 42. Just we had used para four different parameters in this. The x are all our features which we are using, and the y just here is also comma y is our target value or the target which we have to predict, and the test size is basically the size of the data set we are using for the testing part. Here we use 0.2 means 20%. 20% of this data, this is not the whole data. 20% from this data we will use for training part, sorry, testing part, as it's the test size, and the remaining 80% of the data we will use for the training part. In this, we only gives the parameters the test size and by automatically by default, the remaining data is used for the training part. So we will use 20% of this data for the testing part and remaining 80% for the training part. And the random state is where we start our prediction, or sorry, where we start our training the model at which point. So this provides the random state. And now we'll print training on, we will use f string here, okay? So we can simply write here also, we'll use length of x train. We have uses the small s here, x train houses, and similarly print a string and testing on length of y, oh sorry, x test, and this is for the testing. In this, we have divided our dataset into training and testing part. So let's go and check the result. Here you see, if we also write here houses, then here you can see we are training on 5 different houses and testing on 2 houses. As we have total number of houses only 7 in our data set, so we are using 5 for training and 2 for the testing. As we have using a simple example, that's why we have this much or this small the data set. But we can use any CSV file from download from the Kaggle or any site from the internet you can use for practice and solve more complex things. But the basic or the strategy behind using this model is this only. I'm showing you the whole thing, what you have to do to use the multiple linear regression. Just you have to how to train the model and how to predict. But in this, I am using the simple data set so that you can easily understand. Okay, that's why we have only 5 houses for the training and 2 for the testing. Let's go ahead. Let's we have imported all the necessary files, and then we have generated our data set, um, converted the data set into data frame. Then we simply split our data set for the training and the testing part. We use 3 columns or 3 features for the training of the model and the last target feature which we are going to predict. Okay, so let's move back to our presentation and see what's next. Then we will come back to our coding section. Let's go. Moving forward, training the model. Now we will use sklearn to train. When we call model.fit, the computer tries millions of different weights combinations in a split second. It keeps adjusting until it finds the perfect balance that makes the smallest possibility error or the smallest possible error across all the training houses. Okay, So we will use model.fit function, and we will use the xtrain and ytrain parameters variables for training our model. Then we will use xtest for testing. So before testing, let's train our model. Moving back to our coding part, here we are. Let's train our model, and here in this, I will create the model object. Simply use the model as the variable, and in this, we will use linear regression model. This is the model's object, and now we will train the model. Okay, finding the best weights for this. So you will use model dot fit function. Here we go. And in this we will use xtrain, comma, ytrain for the training part. And now we will display the weights. This show which features is the most important in this. So we will use print and the models learn weights. Here we go. And in this we will use coefficient data frame. We will use pd dot data frame, and in this model dot coefficient underscore, and x dot column, and columns, and columns equals to use weights, and simply we will print this df. Here we go. In this we train our model using all these parameters, all these features, and we will training to predict the target feature, the price target variable. And now we will run this. Here we go. Data frame. This is frame E. And here you see the weights. These are the model weights. The model learn, and the model gives different weights to different features. And you can see the model gives the size, the weight of 317.85, and the bedroom is in the negatives, 65306.122, and the age is 918.36. This shows us which parameter is most important in this project of predicting the house price using multiple linear regression. These three are all the features. These three all the multiple features we are using, and in all of this, the age feature is the most important feature. as the weight of the age is the highest, and the bedrooms are the least important as they are in negative. You can see the negative in 65,000 almost, and the size is the middle one. So this in this we train our model. Also, we see we checked which feature is the most important for our for our data prediction, for prediction the target price, the prediction the target, not the target price, prediction the target feature, the price of the house. Okay, let's go back to our presentation part and see the next step. Here we are in our presentation. So after step 3, let's go. Step 4, making predictions. Once trained, we put the model to work. We will give it the features from our test house and houses it hasn't seen before. It uses its learned weight to calculate a predicted price. We then compare the prediction to the actual price to see how close we got. So let's go and see how our model works and how accurately it can predict our or the predict the price of new house. Okay, which it doesn't see in any previous training part. Let's go. Here we again, and let's see. This is the prediction part. In this, we will make the predictions, and first we will use a parameter name as prediction, and for this we will use model dot predict function. Model dot predict, and in this we will use x test, the x test section. Here where it was, here it is, the x test, the 20% of the testing data. We use the remaining 80%, the 5 houses. We use these for the test training part, and now we will use the remaining 2 houses for the testing part. As the model didn't see or it never ever worked on these 2 houses. So let's see how accurately it predicts and how good it is working. Now we will compare the actual versus the prediction. Compare, we will use normal compare PD data frame, and in this we will use actual. Actual is y test, and predicted. Predicted is prediction. It's the prediction only. Okay, let's go and print. We will print Actual versus prediction prices. And now we will print the compare. One thing before this, it's simple variable. So we can write here anything. Don't think that it's any function or here's any comparison technique that I use the name as the compare to compare the actual and the prediction. It's simple a variable. If I write it here as one, we can also use this also the variable. Okay. So I am not using this. I am using simple this and run this. Here you see the actual price and the predicted price. The actual price is 30,000 and the 40,000. These two houses are not used in our training part. Which are the 30,000 and 40,000? Which one is this? Here you see the 30,000 and the 40,000. Here you see the 30,000 and the 40,000, the first two houses. These two are the for the testing part, and in this, the actual price is 30,000, but our model predicted as 26, 2653. It's not 30,000, it's more than that. It's 3 lakhs almost. It's 3 lakhs, but our model predicted as 26, 2653. It's not the exact, but it is close one. See, it's close one. Around the difference of 40, 38 something, 38,000 something. This is the difference. And in the next one, total is 4 lakhs, and the prediction is 33 lakhs 51,000. It is also a close one, not the same. Let's see uh, the next steps, and let's see how our model is working by taking or checking our model, the accuracies and all the stuffs. So before that, let's move back to our presentation. Here we are in our presentation making predictions. We have predicted our house prices. Now let's go ahead and we check our accuracy using the R square. Is we checked? Not now, not yet, but we will check. So this is the main function or the main formula for the R square, R2 score. So before going forward in this, we will go back to our coding part and complete the coding section by predicting and checking our R2 score. Here we go. The last step is checking the scores, and in this we will use R2 score, and here matrices dot R2 underscore score, And for this, we will use wire test and the prediction. See, predictions. Is that the prediction of predictions? It's simple, the prediction. We will use the the actual test, uh, the actual value of the target column, and this is our predicted value. We will using in these two print our model performance, and here we go, model performance. We will print the R2 score here. We will simply print R2 score, and we will check is our model is working more than or has the R2 score of 0.8 or more than that, then our model works. We will check our model score. Is it 0.8 or more than that? Then now we checked our R2 score, and as we see, the model is working good enough, as these are not actually the same, but these are the close ones. So our model is working smoothly and more accurately. If we use more columns or more features in this, or if we increase the data size of our data set, then by training it more perfectly or with more data, it can be, oh, we can increase the accuracy of our model. Okay, so I think this is enough for today in our coding section. So once I will tell you again what we have done today. First, we had imported all the necessary files and the things, all the necessary files, necessary tools we use today. Then simply we created a dataset. You can use any dataset present on Kaggle or internet any from any source. You can use that. We use a simple dataset to explain you in a simple language, though, so that you all can easily grasp it and you can work using different dataset. We simply initiated the dataset, and then we simply print the head or the dataset from the top five values, and the tail function is used for the printing the bottom five values. And then we simply split our dataset into 80% for the training part and 20% for the testing part. And we use three different features: size, bedrooms, and age, for the model to use these three features to predict the last target class, the price, the house price. Then we train our model and see we have checked which parameter or which feature is most important. In this case, the age of the house is the most important. Then we actually trained our sorry, we trained our model here, and then we predicted, and then we checked the R2 score. So I think that's enough for today. Let's move back to our presentation part and see what's next. Here we are again in our presentation. So we checked our accuracies using the R squared score. We also called it as R2 score. This is a number between 0 and 1. If we get a 0.85, it means our features explain 85% of why house prices change. It's a great way to prove that our model is accurately working. So we have checked our R2 score. It is 0.82. It means it gives 82, sorry, 82% of why house prices changes. House price change, and our model is working greatly. So as we have checked, let's move forward. A quick pro tip. Make sure your features accurately related to the target. Okay. However, avoid using two features that are identical, like size in meters and size in feet. This confuses the model. We want unique, helpful clues for the best results. Example, the size related to price. We can use, as we have used the age of the house and the bedrooms. So we can use different unique features so that our model can generate and predict the mm, house prices more accurately. Okay. So with that, great job, you guys. You have just mastered multiple linear regression. You are moved from simple lines to handling complex multidimensional data. This is the foundation of almost everything you will doing in machine learning. Now go find a dataset and start predicting. Thank you.